So I guess we'll talk a little bit about how traditional blockchain development is happening. Traditionally, when people were trying to build out different types of blockchains, what they would do is that they would essentially take an existing cryptocurrency such as Bitcoin or Ethereum, and then they would fork it, change some runtime variables so that they can essentially make it conform to whatever their needs are. As you can see over here, Bitcoin is spawned out of Bitcoin and Ethereum out of Ethereum. Now, at Parity, we've been working on building blockchains for a while. We first built out Parity Ethereum, then we built out Parity Bitcoin, then we built out Parity Zcash, right? And throughout this process, we realized one thing is that we're doing a lot of repetitive work over and over again, and a lot of these different modules that we're using, you could have, a lot of these components you could have modularized them all out. So when Parity started working on Polkadot, they realized that, hey, why don't we actually create this sort of framework for building out blockchains? So that's what Substrate is. Substrate is an open source, modular, and extensible framework for building out blockchains. With Substrate, it provides you with a few different core capabilities. So you have the database layer, the networking layer, the consensus engine, the transactions queue, as well as a library of different runtime modules. And each one of these different modules can be extended and customized for whatever your particular needs are. Beyond that, there are a bunch of other different things that you get with building with Substrate. Notably, one of the big things is that you get interchain connectivity via Polkadot. So we see that kind of as a feature where you can build your self-sovereign chain. And if you'd like to benefit from the interoperability as well as the shared security umbrella, essentially, of the main net, you can easily do so using Kubernetes. Beyond that, we have JavaScript libraries and templates, a lot of different scaffolding tools to essentially make your development incredibly easy, as well as supportless runtime upgrades. So what is a runtime? So the runtime is the block execution logic, or essentially the state transaction function, or transition function. It's essentially composed of different runtime modules. So you can see over here a list of some of the different runtime modules, and you can kind of pick and choose which ones you want to eventually build up your blockchain runtime. And once again, they can all be modified into whatever you like. So just a quick overview of what Substrate's architecture kind of looks like. We have the WebAssembly interpreter, we have the consensus engine, as well as libp, which is a networking protocol which we've all implemented within Rust, as well as the runtime itself, which is written in Rust, and it's built into both native as well as WASM. So Substrate, as you can tell, is all written using Rust. And Polkadot is written using Substrate. So one of the really interesting things to think about is that Polkadot was built, 95% of Polkadot was built using just Substrate. Only 5% of the code is actually adding in that extra functionality of what the Polkadot blockchain is. So it shows you how powerful the framework Substrate is to enable developers to build out these blockchains really quickly. And so if we look at why Polkadot overall, Polkadot we aim to be a foundation for other protocols. And essentially, we want to essentially speed up the evolution of getting to that decentralized web. We do so on 4 different main topics that we kind of focus on. So one being interoperability, so essentially making transactions easier between existing blockchains. We have pooled security, so essentially enabling it enables easy and secure deployment of blockchains with new and interesting value propositions. So essentially, you can kind of focus on the core logic or the meat of your chain, and you don't need to worry about bootstrapping a network of validators to secure your network. Beyond that, we have heterogeneous chains versus homogeneous chains of ETH 2.0, which allows for DApp developers to leverage capabilities of multiple different chains. So I mean, if you're working on a chain, it's not built for a specification or to essentially solve a very specific problem. You cannot optimize it you can optimize it for solving that particular problem. So by having a project chains or project shards, we're able to essentially make sure that we're able to make sure that we can speed up. We can speed up essentially. Yeah, so we have many different types of shards for these application-specific blockchains, and each one of them has their own purpose and then optimized for the particular need. And then beyond that, we have through and through on-chain governance. So essentially, it's going to evolve as the token holder, as the token holders kind of decide on different ways of changing how the system works. And we have runtime upgrades built in into Polkadot itself. So essentially, we can propagate out a runtime upgrade versus like in Bitcoin, where it's like something new, a new version of the node has been created. It's a lot harder to essentially get everyone or all the miners on the network to conform to the new changes. So you can see over here, this is kind of like a grandiose image of what the Polkadot network could look like. Inside, that's the relay chain. Right outside of that, those purple little lines are essentially validators. Outside of that, those little pink squares are pair chains. So it could be like chain link. We could have it could be like 0x or whatever else, different type of blockchain, right? Pair chain essentially means parallel blockchain. And outside of the pair chain itself, you can see that we have these little purple little dots, and those are the collator nodes. And on the all the way outside, you can see those are essentially the bridges into different networks. So we'll go a little bit over the architecture, but essentially there are two core components when we look at Polkadot. We have essentially the relay chain, which is the connector chain, and it provides the strong economic security and the interoperability protocol at the center. We have pair chains, which are essentially these third-party chains that connect to Polkadot for interoperability, scalability, as well as food security. There's a few things that we're not mentioning over here, one being pair of threads. I think early on there was some misconceptions about how much it's going to cost to essentially get a slot on the main chain. Typically, I believe it's somewhere in the low thousands of dots to do so. But we have a concept called pair of threads as well, where you can deploy your contract, or you can deploy your chain to the network overall. You may not have the ability to submit blocks on every slot. However, eventually, once it reaches a certain threshold, it will actually submit to the relay chain. So once again, the relay chain is kind of at the center of everything. It's got validators who are validating on the relay chain itself. We have pair chains, which are essentially application-specific blockchains. And then we have the collator nodes, who are essentially securing the pair chains, or essentially determining which block should be offered next. And I guess this is a little bit more, of a nice picture. A little bit more, so you guys can kind of see how it looks like. And we talked a little bit about bridges. So bridges essentially enable us to connect to external different types of blockchains. Currently, we're working on a Bitcoin, working on an Ethereum, as well as a Zcash bridge, which should all be ready by the end of this year. Just another view of what the overall network looks like. I think one interesting thing to see over here is that essentially the parallel relay chain can connect to another parallel relay chain, which can connect to another parallel relay chain. And so, like down the line, it's something to just keep in mind. So, what's next for us right now? Essentially, we're getting ready for the mainnet launch, which is coming incredibly soon, as well, and it's going to roll out in a similar manner as we rolled out Kusama. One thing to note about essentially the relay chain, which I forgot to mention, is that Kusama will become the first relay chain that's going to be connected to Polkadot once it goes live. And Kusama is our canary net, so if you want to kind of play around with a somewhat live version of Polkadot today, you can do so right now. So we have the mainnet coming out incredibly soon, and you guys will be able to essentially play your dots also incredibly soon. Can't give you guys dates, but we're working on it, and it's almost there. So overall, how can we work together? We have the ecosystem fund, so the Web3 Foundation and Polkadot Capital, we've created a small venture capital fund for different ecosystem projects. We have a treasury, which is an on-chain treasury, which can be used to essentially fund different initiatives, such as fair chain development kits or communities or whatever else that essentially the treasury wants to put money out for and allow for funding for those projects. And beyond that, we have Web3 Foundation support. So over at Parity, there's something called the Builders Program. So if you guys are looking for any sort of extra help beyond just what you get on Riot, and you want support directly from the runtime engineers, you guys can sign up for that sort of program over there as well. So yeah, that's all I've got for you guys today.